In this video, we're going to take a look at creating our second OTL, which will be the first step in the actual tentacle setup itself. So if I go ahead and dive into my tentacle setup here, what I'm talking about is this first network box here. Now, we said that we were going to be creating mostly object-level OTLs, so let's just go ahead and copy-paste this out. So Control-C to copy, and let's just go ahead and create a subnet. I'll just call it tentacles create lines v01. And notice that, again, I'm putting the underscore at the end just to prevent situations like v011 when we eventually start instantiating this OTL. So I'm going to go ahead and just dive into this subnetwork. And let's create a geometry node to contain the actual operation of creating the lines. And I'll just call it create lines, because why not? Dive inside here and just go ahead and paste that part of the setup. I don't really need this network box anymore because all the nodes inside this geometry node are related to creating lines. So I'll just go ahead and delete that. I'll leave this to-do note here because we'll be dealing with that in a minute. For now, I'm just going to go ahead and add an output null at the end here. And then let's go ahead and create our OTL. So I'm going to go ahead and right-click and say Create Digital Asset, which brings up this dialog that by now we should be familiar with. I'll delete my username out of it. I'm just going to go ahead and put it somewhere meaningful and hit Accept. And now we have our nice type properties dialog. Now, one of the things that is kind of interesting about object level OTLs is that when you're at object level, the wires have sort of an intrinsic meaning that's different from SOP level, right? They mean inherit a transform. And a lot of people like to use lines at object level to also mean send geometry from something into my OTL. I kind of like doing that because it feels really visual and it's really easy to tell how things are wired together. But I also don't like losing the meaning of what a line is at object level. That is, that a line is supposed to be a transform. So what I'll usually do is I'll have one input dedicated to the transforms, and then the rest of the inputs will be dedicated to retrieving geometry from elsewhere in the network. So for our create lines OTL, we're going to be wanting to just grab our emitter to scatter points onto in order to create our lines. So let's just use two inputs, so that we have one for the transform and one for the emitter to wire into. Now, it's a good idea when we create OTLs to name our inputs and outputs, and we can do that on this Input-Output tab. So if we go here, we can see that it's just subnetwork input number 1 and number 2, which is the default from when this was a subnet. So we can just rename it to xform for the first input and emission surface for the second input. And for output, I'll just say tentacle lines. Notice there are these isReference checkboxes over here, and that's kind of useful because you can turn it on and Houdini will actually make the wire a dashed wire to show that it's different from, for example, a transform. So just hit apply, and I'll just show you that dashed wire right now. You can see it's kind of dashed. And then if I do a null to use as a transform, it's just a solid line. So it's visually, you can tell that they're different things. Just delete the null for now. And let's hit accept and make this start working. The first thing is, if we dive inside, I want to go ahead and wire up my create lines node to the transform so that it picks up that transform. And let's just go ahead and create another geometry node that will represent our output. And just dive inside and create an object merge. I'll call it get create lines. We want to change the transform to into this object because we want to be sending out flattened transforms from our OTL. And if we go to the node picker, Remember, we always do relative paths when we are merging geometry from elsewhere inside our OTL. And in this case, I just want the create lines node. So now if we come back out, all right, now the next step is to start promoting parameters. But at this point, I kind of figure that you are pretty familiar with how to promote parameters to our OTL. So I'm just going to go ahead and pause the video and do the business of promoting parameters so that we can move on to the next topic. Okay, so all I've done here is promote the parameter that gives us the number of tentacles. So I could say 300, and suddenly we have double the number. We have a parameter to change the direction of the tentacles. So let's do this. And notice that we're doubled up here as far as geometry goes, and that's just because I forgot to turn off my tentacles setup node over here. If I go to the length tab, I have controls for how long and short the tentacles are. I can control the noise settings, so I can make some of them longer. I can make some of them shorter if I want to. And we can change the distribution and the element size for how frequent the long tentacles are. And under writhing, we just have some controls for the animated noise that plays. So we can change things like how fast the tentacles writhe and that sort of thing. So one thing that's kind of important is that we have our emitter hooked in here to our input, but we haven't actually done the business of making it use that emitter, and we're still just using a grid. And we have our handy to-do note here to remind ourselves to replace that. So I'm going to go ahead and delete that because we're going to just fix that right now. Let's just delete the grid. And we're just going to create an object merge node to bring in the emission geometry. So I'll name it something like get emission surface, just to make it clear that we're getting it. And maybe I'll just go ahead and color it blue just to preserve that convention of blue things are inputs. So the way that we want to get our emission surface is going to be through the use of an expression. And all we want to do is reach up to this node and say, what's plugged into my input? And that in this case is the create emitter node. So we can do that with the op input path expression. And since we're in a string parameter, we do need to use backticks to denote that we are using an expression instead of just a raw string. And we'll just type op input path. And in quotes, we'll just give it the path to the node that we want to get the input of, which is our parent OTL. So we do one ... to get to outside of this node, so out into this area, and another ... to get up to the parent OTL. And then the second argument for op input path is just the index of the input that we want to grab, which in this case is 1. Since it starts at 0, 0 would be the X form input, which is here. So we don't want that one. We want input number 1, which goes to the emitter. Let's go back inside here. And the reason why it's giving us a warning is because it doesn't actually know which thing to grab inside of the emitter OTL, because if you remember, the emitter is also a subnet OTL, and it contains a bunch of different geometry nodes, and Houdini doesn't know which one we want. So we'll just tell it for now we want to get the output node. So we just type /output there. And if we want to see what this resolves to, remember that we can middle click on the label of the parameter, and that shows us what the expression is resolving to. And then middle click to get the expression back. So that's great. So now we are actually grabbing the emitter. If I just come back out to object level, we're actually grabbing the emitter to generate our tentacles on. And if we want to, we can just plug it into the other camera's emitter and we still also get our tentacles, which is pretty cool. I'm just going to use this one for now. Now, it's pretty neat that we can change the direction of the tentacles with this parameter, but it's a bit cumbersome to try to get exactly which direction we want using parameters like this. You'll notice that elsewhere in Houdini, we usually don't have to do this. Usually we have a viewport handle to handle that. We can create a viewport handle for our OTL easily enough. I'm just going to go ahead and revert this to defaults by right-clicking and going to Type Properties, and then going to the Handles tab. And under the Handles tab, we can pull down this menu to see a whole bunch of different types of handles. And I would encourage you to explore and look at what each of these things do. Honestly, most of them you'll probably never use, but it's cool that they're there. The one that I use the most is the transformer, which just has a whole bunch of things that we can put into it. You can see that each one of these represents a parameter. We'll look at how that works in a minute. But for now, what we're going to look at is using a vector handle, because what we want to do is let the user specify a vector that represents the direction that we're going to be shooting our tentacles out. So the way this works is we can take some parameters off of our OTL interface and put them into these fields to tell the handle to control those parameters. So for Vx, Vy, Vz, that's the actual vector that the handle is outputting. So we want to put that into our direction parameter here. So all we have to do to make the handle control that parameter is just say direction X here, direction Y here, and direction Z here. And now when we hit apply, and in fact I'm just going to hit accept to dismiss the dialog. Make sure that we have our create lines node selected. Put our cursor on the viewport and hit enter. And here's our cool handle here. And we can see that we can now control the direction of our tentacles using a friendly handle instead of having to deal with this complicated mess of a direction. But what happens if we were to, for example, take a null and plug it into our camera and just move our camera and therefore our emission surface way off into somewhere else that's not close to the origin? Now, if we go to our tentacles setup and we bring up our handle, it's very inconveniently still at origin, which is kind of annoying, and it makes it hard to use the handle. So the way that we can fix that is by bringing our type properties dialog back up, and we'll need to create a new parameter for this tx, ty, tz parameters to control. So I come over here to parameters. I'm just going to create a new vector parameter. I'll just put it at the top. We're going to make it invisible anyway, so it doesn't really matter where we put it. We just need it to be there. I'm going to call it direction origin. And just hit apply. There it is. And then what we want to do is make sure that this parameter is always set to some value that will be the origin of our vector. So if we go to channels, we can just give it default values, like some kind of centroid expression. Now it's a bit cumbersome to just figure out which node in our create lines geometry node that we're going to be referencing. So I'm just going to go ahead and create an out null here. Plug it into the object merge, so it's just the emission surface itself. And we'll call it emission surface out. And I'm just going to copy that name so that I can use it in my expression over here. And let's just say the expression is centroid. And the path for the centroid is / create lines / emission surface out. And then I need to tell it which component of the centroid to use. In this case, it's X, so I can just put d_X there. And I'll just copy it. And for the Y component, we'll do d_Y. And for the Z component, we'll do d_Z. And hit apply. And of course, we now have our beautiful direction origin here. So now if we go over to our handles and we just hook it up to our tx, ty, tz components of the handle, we can say direction origin x. I'll just copy it. Direction origin y, paste direction origin z. And now if I hit accept and I select my create lines OTL and hit enter, my handle is now stuck in the middle of where my emitter is. So it makes it so that no matter where our camera is, the handle is always in the right place. And another kind of cool thing about this is if we put down another null and we hook it up to our transform input, and we just move our tentacles again somewhere else, and then display our handle, you can see that it moved the handle as well, and we just get that for free because Houdini applies the incoming transforms to the handle of our OTL. All right, so I'm just going to go ahead and delete these weird other transforms to get everything back into place. And there's one last thing that we want to do with this OTL. It'd be pretty cool if we could control where the tentacles actually are on the emission surface. Right now, they're kind of evenly distributed across it, and it'd be neat if we could be able to say, like, oh, I want to have higher density of tentacles here and lower density of tentacles over here, or something like that. And this kind of thing is a good habit to get into when we are turning setups into OTLs. We want to look for ways to create control hooks for the user. In other words, we want to try to find ways to make the setup more usable without unlocking our OTL. The less unlocked OTLs our users have, the happier we'll be as people maintaining those OTLs. So the idea that I have is that it would be cool if our users could just paint where the tentacles are on the emission surface. So let's just go ahead and go inside and set up that system really fast. This will be a side system of sorts. Let's put this up here. And I'll just display the emission surface. And if we go to wireframe, we can see that we don't currently have any geometry to paint onto. So I'm just going to go ahead and say divide. I don't need convex polygons, I just want two bricker. And that gives us a nice sort of grid to paint onto. Then we're going to create a paint sop. And since we're just going to be painting, let's say, red in order to tell it where to put the tentacles, I'm just going to add a color sop beforehand to make it black. Except that black is really hard to see, so let's just make it blue. And then our paint sop will be red by default, and maybe just make this a little bit bigger. Maybe I'll just do something like this. There, it's beautiful. It kind of looks like a guy rocking out. And I'll just go to my scatter and say density attribute, CD, and we can see that we have scattered our tentacles. And then just to make sure that we haven't messed anything up, because even though we did run through the setup earlier and we feel like we have a pretty good handle on how everything works, it's a good idea not to leave things around that might screw things up. So we're just going to go ahead and do an attrib delete. And I'm going to delete the CD attribute. All right. Now let's put the display flag back down here. We can see that we only have tentacles where we painted, and that's all well and good. But now, how do we allow the user to use this paint sop? Because you'll notice if we come back out and we say save node type, match current definition, we said that the goal was to stop people from having to unlock our OTL under certain circumstances. And if we come inside right now and we try to paint, it doesn't work. And the reason for that is obviously our OTL is locked. So it would be pretty cool if we could tell Houdini, well, everything needs to be locked except for that one node. Unfortunately, we can do that. I'm just going to allow editing of contents, go to type properties, and we can go to the node tab. There's this field called editable nodes, which allows us to tell Houdini not to lock those specific nodes. Now, this is quite dangerous, and I'll explain why in a second. The use that we're using it for the tentacles OTL here is, I think, valid, but lots of people can use this in ways that get them into trouble. So let's just go ahead and show how this works first, and then we'll talk about how to avoid getting ourselves into trouble with this. So if we hit apply, I'm just going to dismiss the dialog, and then we'll match current definition. And now when we dive inside, we can see that the paint stop is no longer grayed out. And if I select it and start painting, we can in fact paint where the tentacles are, which is pretty cool. Now, the way that people can get into trouble with this is by not thinking about the fact that since this node is not locked, that node's values are saved into the HIP file, not into the definition of the OTL. So what'll happen is you'll get a default when you put the OTL down based on what the node's state was when you saved the OTL's definition. But once the user changes it, if you need to change any values on that node, it will not update in other people's HIP files. So for example, if you have another create lines OTL over here, and let's say that rather than thinking, oh, I want people to be able to change things on this node, and I don't care what any of the parameters are on it. Instead, let's say that somebody was thinking, well, I have this line and I want to, for some reason, use a Python script to set the value of this direction parameter. So I'm just going to make it editable so that I can do that. So if we make our line editable, that's cool. It won't let me multi-select. Okay, I guess it just adds it. So let's hit apply, unlock and save, and then I'll just go back up and save node type and match to current definition. And now let's say that, oops, I actually need to change something on this. I need the origin to be 1. So that's cool. I'm going to go ahead and save that. So I'll allow editing of contents, I'll save node type, match current definition, and then as the designer, maybe I put down another one just to make sure that it took. Dive inside, and I see that my origin was changed, and I just assume, okay, yeah, that means it's fine. But the problem is that my user who already had an instance of the OTL put down, if he goes inside and looks at it, the origin isn't changed. And this is why editable nodes can be really dangerous, because you can't propagate changes to editable nodes using just like a save and match current definition workflow. So generally speaking, as a rule of thumb, I tend to say that you should never ever use editable nodes unless the node that is editable does not contain any parameters whose values you care about. So in other words, you want to make nodes editable that you want users to entirely control. All right, so I'm just going to delete these other create lines OTLs and allow editing of contents here. I'm going to remove line 1 from the editable nodes list because we said that was dangerous. Hit apply. Dive inside. I'm going to get rid of that origin parameter so that everything is back to normal. Now the other thing that would be cool is notice that if we match current definition, say someone's using this OTL and it's all great and they're like, okay, I want to paint. And then they dive inside and they realize that there's this complicated node network inside. And I know this node network isn't actually complicated, but let's just say it was complicated. And then they're going to have to go through and search and try to find the paint SOP that we left for them, which is a little bit annoying. The way that we can fix that is by using the dive target parameter. So I'm just going to go ahead and go inside. And let's just drop this paint SOP into a subnet so that we can have it isolated in a network. Because the way that the dive target works is you can specify a node, and when the user dives into your OTL, it'll automatically go there. And I'll show you how that works in a second. So I'm just going to call this paint subnet. And let's just say the dive target is create lines, paint subnet. Hit apply. And now when I come out and save match, now when I double click, I automatically go inside the paint subnet node. And we're ready to go to start painting. Now notice that our editable node path was broken, so we just need to fix that really fast. Apply, unlock and save. And sorry for coming in and out so much. I just have to be able to come back up here to the top level to match current definition. And now we dive inside and we're ready to start painting. In this video, we looked at how to create the create lines OTL, which is the first step in the actual tentacles setup. We looked at how to add a handle so that the user can change the direction of the tentacles really easily. And we looked at how to add a system to allow the user to just paint where the tentacles are on the emission surface. In future videos, we'll continue adapting the tentacle setup into OTLs and look at additional ways that we can provide controls to the user to make their lives a little bit easier and also make it less likely that they will unlock our OTLs, which makes our lives a little bit easier.